There is a lot of interest in cover crops these days. One of the many benefits of cover crops is their capacity to supply nitrogen to the following cash crop. Farmers who use cover crops often wonder how the cover crop might affect how much nitrogen they need to supply to their crop. Scientists at the College of Agricultural and Environmental Sciences at UGA have developed a cover crop nitrogen availability calculator to help with this problem. The calculator predicts the amount of nitrogen released by a cover crop over the cash crop growing season and can help farmers decide whether they can reduce or increase the amount of nitrogen fertilizer. In order to run the calculator, the amount of above-ground cover crop biomass and the cover crop quality needs to be known. In this video, we explain how to take a representative cover crop biomass sample and how to prepare a subsample to be shipped to UGA's Agricultural and Environmental Services Lab to be analyzed for the nitrogen availability calculator. Just like with soil sampling, the information you get back from the lab is only as good as the sample you send in. It is important that your cover crop sample be representative of the field. To do that, you have to take multiple cover crop subsamples of a field, just as it is important to take multiple subsamples for a routine soil test. Multiple samples ensures that variations within the field are taken into account. For more information on how to choose where to take cover crop subsamples, see the cover crop biomass sampling circular that accompanies this video. The equipment for taking a biomass sample is fairly simple. You will need a prepared U-shaped quadrant like the one made here. Pieces of connected PVC work nicely. Extra length is left on the quadrant in order for it to be easily slid into the cover crop. The 2-foot length should be marked on the quadrant. Small cover crops, like clovers, can be sampled with a 1x1 foot quadrant. Depending on the size and thickness of your cover crop, scissors, shears, or clippers may work the best to clip the cover crop at ground level. You will need a clean tarp, a 5-gallon bucket, or some other container to collect your samples. Weigh the container in which you will be placing the cover crop sample. You will also need a scale that weighs in grams or pounds. Finally, make sure you have a prepared data sheet, like the one found in Appendix A of the Cover Crop Biomass Sampling Circular. Once you have all of your material together and have determined where to take your subsamples, it's time to go take the samples. At each of your predetermined subsample sites, choose a place where there is consistent cover crop stand and randomly select where to sample. In this case, we threw the quadrant to randomize the sampling. Slide the quadrant into the cover crop at your random sample location. Make sure all of the plant material within the quadrant is rooted inside the quadrant. Gently pull the cover crop out that is rooted outside the quadrant and pull all of the cover crop that is rooted inside the quadrant into the quadrant. You should only be sampling cover crop that is rooted inside the quadrant. Once your quadrant is in the cover crop and you have adjusted all the cover crop that needed to be moved, clip all the plant matter inside the quadrant at 1 inch above ground level. Place it in the clean bucket or on a clean tarp. Try not to include soil. You can weigh each subsample collected in the bucket and record the weight or place your subsample on a tarp to composite the samples for a field or section. Then go collect your next subsample. Repeat until you have taken all the subsamples that you need to take. When you are weighing your sample, make sure to write down the weight of the tarp or bucket the sample is in. Here we use the plastic container to hold the composite cover crop sample in the tarp. We put the tarp into the container to make it easier to handle. We will record both the tarp weight and the plastic container weight and subtract both from the total weight recorded of 4,310 grams, or 9.5 pounds. Keep all of the subsamples together by placing them on a clean tarp. A subsample of all of the samples you have collected will need to be taken and sent to a UGA lab for the cover crop nitrogen availability calculator. Calculate the fresh cover crop weight using the data sheet from Appendix A. For our example, we just have one composite sample from the field, and we have converted the grams into pounds. First, we have the weight of the empty bucket or tarp at the top of the data sheet, which was 3 pounds. Remember, this was both the plastic container and the tarp. The total weight for the composite cover crop subsample was 9.5 pounds. We subtract the bucket and tarp weight from the total weight and record it in the second column. Let's say we repeated this process with a second composite sample of 3 subsamples. The weight of the empty containers stays the same at 3 pounds. This time, our total weight was 7 pounds, so we will record 4 pounds in the second column. We will add together all of the second column. Take that sum and divide it by how many samples we took to get an average. In our example, this is a little tricky. We had 3 subsamples in each composite sample, so the answer is 6. We were using a 2 square foot quadrant, so we will plug that into our equation. 6 samples times 2 square feet gives us 12. We divide the sum of that weight in column 2 by 12 to give 0.88 pounds of cover crop per square foot. Then multiply it by 43,560 to convert it to pounds per acre. Our number is 38,115 pounds per acre. Record that on the data sheet. Now you know what the average cover crop biomass is for your field in fresh, wet pounds per acre. This number will be much higher than the amount of biomass you think about generally for cover crops, because there is so much water in fresh cover crop, and cover crop biomass numbers are reported on a dry weight basis. In our example, the moisture content was 83%, so the equivalent dry biomass was 6,480 pounds per acre. To be able to predict how much available nitrogen is in the cover crop, it needs to be analyzed for nitrogen and quality parameters. This means we need to send a representative subsample of the biomass to the Agricultural and Environmental Services Laboratory. You will need several other items for this step: gallon-sized plastic bag, permanent marker, ice pack, and a shipping container. Take all the subsamples collected from the field and combine them into one sample on a clean tarp. Mix all the subsamples together thoroughly. Form a circular pile and split the pile into 4. Keep 2 diagonal pieces of the 4 and discard the other 2. Mix the 2 piles and repeat the reduction process until the remaining sample will fill a gallon-sized sealable plastic bag. In general, you should clip or chop to reduce the size of the sample. Clip, chop, or tear the material into pieces around 2 to 3 inches. Make sure the sample has dry ice or an ice pack in the package. Deliver to the lab the same day or send it overnight. Send the sample with a submission form to the Agricultural and Environmental Services Laboratories at UGA. The submission forms are available online at www.aesl.ces.uga.edu. county.edu/forms. Please fill out all information. The farm address and the county submitting the form will be used to pick the nearest weather station to run the calculator. Other critical information is if you will be incorporating the cover crop or leaving it on the surface, the date the cover crop is killed, the wet biomass weight, the planting date for the upcoming cash crop, and the cover crop species that are in your sample. One final thing. Indicate whether legumes are more than 40% of any cover crop mixture that you are sending in. This affects the analysis. Cover crops have many advantages and can help your farm improve its fertility. One way to know how much nitrogen cover crops supply is with the cover crop nitrogen availability calculator. Remember, your county agent is a great resource and can help you if you have any questions. Happy cover cropping!